This is the determinant and inverse of a 2 by 2 matrix. Given that matrix A in the first row has entries 2 and 4. In the second row, we have 3 and 1. Find determinant of matrix A. 2. Inverse of matrix A. Solution. To find the determinant of matrix A, we consider the diagonals of the matrix. This is called the major diagonal, and this one is called the minor diagonal. The rule with matrices, we always begin with the major diagonal. So in our major diagonal, we have 2 and 1. Let us multiply the entries in the major diagonal. So we say, open parenthesis, 2 times 1, like that. So we are looking at 2 and 1, 2 and 1, minus minor diagonal. So this is the minor diagonal. We have 4 and 3. 4 and 3, like that. Let us simplify. 2 times 1, it's 2, minus 4 times 3, 12. 2 minus 12, negative 10. It is always important to note that when we are doing subtraction of integers, given that the numbers have different signs, 2 has a positive sign, 12 has a negative sign. The signs of these numbers are different. So when the signs of the numbers are different, we subtract. So 2 minus 12, we get 10. But why are we getting negative 10? The rule, we always get the sign from the number which is numerically larger. So 12 is bigger than 2, so we get the sign from 12. The answer is negative 10. Now, let us look at the inverse of matrix A. To find the inverse of matrix A, we say A inverse. So this is the notation for the inverse of a matrix. A with a negative 1. So the inverse of matrix A is equal to, we write 1 divided by the determinant. 1 divided by the determinant. Our determinant is negative 10. That's the rule. So you always put a 1 on top, then you divide by the determinant of the matrix. Then we open parentheses like this. You can close in advance. Now, let us look at the original matrix A. So we are going to do a simple transformation. This one will take the position of 2, and this 2 will take the position of 1. They will swap. 1 and 2, like that. As for these other numbers in the minor diagonal, we just change their signs. This number is a positive number, so we change it to negative, so it becomes negative 3. This number is a positive number. We also change its sign. It becomes negative 4, like that. In short, we just say multiply the entries of the minor diagonal by -1. So -1 times 3, we get -3. -1 times 4, we get -4. So that is the rule. At this level, we can distribute this fraction 1 over -10 so that it multiplies everything in parentheses. 1 over -10 times 1. So this is 1 over -10 times 1. The 1 is not a fraction, so we can write over 1. Multiplying this, 1 times 1, we obtain 1. Then -10 times 1, we get -10. We continue distributing throughout other terms. 1 over -10 times -4. So this will give us, we have 1 over -10 times -4 over 1. 1 times -4, we get -4 over -10 times 1, we get -10, like that. We distribute with the terms in the second row. 1 over -10 times -3, this will give us -3 over -10, following the same rule. Then on the other side, we have 1 over -10 times 2, we get 2 over -10, like that. We close. There are numbers which can be simplified. So these fractions can be reduced to their lowest form. 1 over -10, this one is already in its lowest form, we maintain. Then negative divided by negative, the answer is positive. A number which goes into 4 and 10 without leaving a remainder. 2 into 4, we get 2. 2 into 10, we get 5. We close. A number which goes into 3 and 10 without leaving a remainder, there is no number, so we leave it like that. Negative divided by negative, we get a positive, so this will be 3 over 10. On the other side, this can be reduced by 2. So 2 divided by 2, the answer is 1, like that. Then 2 into 10, we get -5. So this is our final answer for the inverse of the matrix. So just reducing this fraction and we have this. So 2 goes into 4 and 10. So we say 2 into 4, we get 2. 2 into 10, we get 5. So don't forget to divide. Negative divided by negative, we get positive. Just like that, we reduce the remaining fractions and our final answer will be this one.